Hi guys. I said I was going to do an engineering video, and I try to mean what I say. And so here's an engineering video coming up. But before I start the engineering video, I want to say something to preface it. I had an idea that came to me concerning haters, because it seems to be a constant uh, subject for me. Oh, but whatever. I think there's like two kinds of haters, at least we can say. There's natural haters and synthetic haters, for lack of a better word. I think a natural hater is someone who really has a reason to hate. I mean, in the Bible, Jesus hated the money changers or whatever. He hates iniquity, and he hates Satan, and he's righteous. So hate can't always be wrong. God himself hates the wicked. Oh, no, hates wickedness or hates sin or whatever. I shouldn't say, whatever. Well, those kind of haters can hate me if the hate's concerning me. They can hate me, and then if I fix the thing, then they should stop hating. If that's natural hate. If it's synthetic hate, they're just haters, and it's more them than me, which means if I change it, whatever they're hating me, they're just going to hate me on something else. And no matter what I do, they're always going to be haters, because it's not natural hate, it's synthetic hate. It's the hate's about them. It's about their state of whatever that makes them hate me. And I have a couple of those. One of them goes from thing to thing, and then he starts making stuff up, and I have to report it because it's inaccurate and it gets deleted, which then he can hate me for that. But he started with things that were not true, but then I proved them wrong, so he just goes to things that are flat out makes things up and really bad, and just makes things up and says true fact, and makes things up about me, and then whatever, and then I report him, and he'll just go on hating me to probably the rest of his life. But that's synthetic hate, because it's not, nothing I do changes the hate. Therefore, the hate is more about him, maybe all about him, and not about me, or whatever, not at all about me, whatever. And I have to realize that those synthetic haters have their own problems, and I have no business making myself miserable because they're synthetic, because synthetic haters exist in this world. So anyway, that's just a preface to that. Something told me to say that, because I think I have not been reading my comments lately, because I just haven't had the time. I will though, but I suppose some people might have been hating me because I said I'm going to do this video and that video, and maybe I don't for a while, and they think I'm not going to. I don't know. I haven't even read them. Maybe that's not just in my head. But anyway, I said I was going to do an engineering video, and I will. I said I was going to do David Roth, Shy Boy, and I did. I'm sorry if I'm not sorry, but it's just a saying. I'm sorry that I bought a guitar today, which took a lot of my time, and I had to get it set up. It still wasn't set up when I did the 2 takes of Shy Boy, but it's getting better now. I'm setting, it's better than it was. And setup is important with guitars. It matters how they sound and how they play. And anyway, okay, so engineering video. I want to cover three little things in this engineering video. One's a thing, for lack of a better word, Euler's identity, and then I want to cover a famous little fun miscellaneous identity of complex variables or complex analysis, and then I want to cover De Morivie's theorem. It may sound harder than it is. Okay, so remember my last, I'm trying to get this set up where you guys can see the board accurately. Sorry if I'm failing at that. Let's see if you guys can see the board good. Okay, so I've said before, I brought up Euler's theorem before, and I brought up the complex plane. For review, the complex plane is a plane, which is a two-dimensional structure, that is the x value, the x coordinate, the x-axis is real, so that'd be x, and the y-axis is imaginary, so it'd be I, y. And then, just for lack of a better letter, z is a complex variable, a complex number, which is x plus I, y, because it's the sum of a real number and a complex and an imaginary number, which we call complex number, for lack of a better word. And this z, if it's a circle, and I'll say radius, oh, that's a beautiful circle somehow. If that's radius 1, then it turns out that there's a thing called Euler's formula that says, do I have an eraser somewhere here? Euler's formula, which is really quite brilliant, much of systems engineering is based on it, is e to the I theta equals cosine theta plus I sine theta. And theta is the angle starting in the x-axis, measured counterclockwise in the positive direction, and measured in radians, which is such that 360 is 2 pi, 180 is pi, and 90 degrees would be pi over 2, because we're making it as if how long of an arc, how big is the arc that would be measured by the angle if this radius is 1, We all know that, well, it's true that circumference is pi over the diameter, but the diameter is 2 times the radius. So circumference is, I mean, the pi, pi is equal to circumference. Pi equals, no, wait. Yeah, circumference over diameter. But diameter is 2r, twice the radius. That's not even, that's RC, like in cola. Jeez, man. 2d is 2r. So the circumference is, so c equals 2 pi r. 2 pi times r. I'm running out of room in this little board. C equals 2 pi r. And therefore, if r is 1, then c equals 2 pi. And since c is a whole revolution, that would be the whole, then 360 degrees would be 2 pi radians. That would make 180 degrees pi radians, and 90 degrees would be pi over 2 radians. It's, I mean, I don't know if that's simple or hard, but that's just how it is right there. Okay, sorry if I cluttered up my board, but at least I wrote it right and said it right, I think. But here's an interesting thing with e to the I theta equals cosine theta plus I sine theta. There's something called Euler's identity, and that's when you plug in, on purpose, plug in pi into that equation. And so pi would be 180 degrees in degrees. So we have e to the I pi equals cosine pi, but cosine pi is -1 because it's the cosine is adjacent over over the hypotenuse, and also, yeah. So and so also if theta equals pi, we're over here, which is, we know already just from sight that that's going to be -1, but let's work it out. Cosine pi equals -1, and so that's but it's e to that pi equals cosine pi plus I sine pi. But cosine pi is -1, so we're going to have e to the I pi equals -1, because that's cosine of pi, plus I sine pi. But sine of pi is 0, because it's sine is the opposite over over the hypotenuse. So that would be, so sine, since sine pi is 0, that's negative. We have e to the I pi equals -1 plus 0. Well, adding 0 doesn't do anything, so that just gives us, let me do it over here, because that is this, oops, there goes that. Is it over here? To continue, e to the I pi equals, can you guys even see that? I hope you can. Equals -1 plus 0 equals -1. Okay, can you guys see that? I hope I just said that, didn't I? Okay, so that means that e to the I pi equals -1. And if e, so let me erase, believe it or not, I'm going to erase the whole graph part, because I need to have room to write here. I hope you guys can see that. Is the lighting wrong? I hope not. Okay, let me, no, I don't want to do this video over if it doesn't write out right. No, but I hope it does right. Let me erase this. Okay, so e to the I pi equals -1, which means that e to the I pi plus 1 equals 0. Just adding 1 to both sides. E to the I pi plus 1 equals -1 plus 1 equals 0. And this e to the I pi plus 1 equals 0 is called Euler's identity. Is it so? Anyway, it's a bright thing. Yeah, that's called Euler's identity, and it's very, very, very cool, because it has E, which is a transcendental irrational constant, valued at 2.718281828, goes on and on. I is the square root of -1, such that I squared equals -1, imaginary number. Pi is a ratio of a circle's diameter to circumference, and it's, I mean circumference to diameter, and it's also a transcendental irrational number. constant, and its value is 3.14159.265 and goes on and on. So those are three of the most weird, constants in math, right, in that same formula. And also has 1, which is the number that multiplied by 1, it stays the same. So it's called the multiplicative identity. So that's an important number. 0 is the additive identity, because if you add 0 to something, it stays the same. So it has 0, 1, e, I, pi. Those are 5 of the most important constants in all of math, all in the same equation. Plus it has addition, there's the plus, multiplication, because it says I times pi. I pi means I times pi. And it has exponentiation, because e to the I pi is exponentiation. So it has 0, 1, pi, I, e, addition, multiplication, and an exponentiation, all in one formula. It's considered one of the most beautiful formulas in math, maybe the most beautiful, I don't know. But it also, people have asked, what does it mean? And all the best people can say so far that I've heard is it means something we just don't know. Or maybe backwards. We don't know, but it must mean something, or whatever, something like that. Okay, that's Euler's identity. That's one thing I wanted to cover. The next thing is I want to do another little trick with Euler's formula. I know it's going to be boring, but to you math nerds, at least you might maybe get some review here. Okay, if you have e to the I theta equals cosine theta plus I sine theta, let's plug in pi over 2. So in pi over 2, you have a circle, and it would be up here, and that would be, we're going to know that's going to be I, because that's the x value is the, because pi over 2 is 90 degrees, so that's right here, and then the x value of that would be 0, so that, and then the y value would be 1, so you're going to have 0 plus I 1, or you're going to get I. But let's just work it out just a little bit harder first. So e to the I pi over 2 equals cosine pi over 2 plus I sine pi over 2. We're just making theta equals to pi over 2. Okay, so cosine pi over 2 is 0. It just is 0. So e to the I pi over 2, yeah, right, is 0 plus sine pi over 2 is 1. So that's going to be plus I times 1, which 0 plus I times 1 is I. So e to the I pi over 2 equals I. Now what's cool, what you can do with this is first let me erase here. Okay, erase here. Okay, here we go. All right, so e to the I equals I. Okay, so e to the I, so let's put it right, let's rewrite it up here. E to the I pi over 2 equals I. What's cool is that you can take the I power of both sides, and you get e to the I pi over 2 all to the I power equals I to the I. So you get e to I to the I equals e to the I pi over 2 to the I. But then I may not even do the more from, because this is already, seems like this might be enough. E to the I pi over 2 to the I is just e to the I times I pi over 2. That's a rule in math. If you have an exponentiation of something that's an exponent, you just multiply it by whatever the explanation is, coefficient, whatever the explanation is, the exponent of the exponentiation. So that would be e to the I times pi over 2. But I times I, since I equals the square root of -1, I times I, or I squared, equals -1. So this I times I is just -1. So you have -1 times pi over 2. -1 times pi, that's even worse, times pi over 2 equals I. What do we have over here? I to the I. So what you have is I to the I to the I equals e to the minus pi over 2. Because this was I here. Yeah, I to the I equals e to the minus pi over 2. And what's interesting about this, and let me rewrite it, but let me rewrite it up. Let me rewrite. You guys can go back in the video if you didn't get all that, and plus I need the room. So here we go. Minus I. So I basically have I to the I equals e minus pi over 2. What's interesting about this is that this is an imaginary number to an imaginary power. Can you guys even see that? What's wrong with my lighting? It's an imaginary number to an imaginary power, and yet e is real, pi is real, 2 is real, and so this all is a real number. So imaginary number to an imaginary power is a real number, which is very interesting. So let me rewrite it again. I to the I equals, now let's do a little trick here to make it look different, but not really mean anything different. When you in exponentiation, something to the negative power is 1 over the thing to the positive power. So e to the minus pi over 2 is 1 over e to the pi over 2. Okay. But then things that are when something is the exponent of something, the top and it's a if something is if an exponent is of a fraction, the top number is the power and the bottom number is the root. So that would mean that e to the pi over 2 is pi is the power, so that's equal to e to the pi, and then 2 is the root, so that would be the power the root would be 2, so that would be the square root of e to the oh yeah, that's right. Wait, let me get this right. Oh yeah, here I go. Yes, e to the, okay, I almost got confused. E to the pi over 2 is e to the pi, but the square root of that. So e to the, it's not writing it right now. E to the pi over 2 is a square root of e to the pi. Oof. So that would mean that 1 over, so that would mean that I to the I, since it's 1 over the square, since it's 1 over e to the pi over 2, that would mean that I to the I is 1 over the square root of e to the pi, because e to the minus pi over 2 is 1 over e to the pi over 2, and e to the pi over 2 is a square root of e to the pi. So I to the I equals 1 over the square root of e to the pi. Okay, let me rewrite it up here. If you guys if you guys know this in math already, you guys can follow it, and you'll know if I'm right or not, because you know the math. If not, maybe you'll learn something. Cool. So I to the I equals 1 over the square root of e to the pi. I'm getting tired of writing, I guess, because I'm writing really bad. E to the pi. So that's a neat little formula there too. That an imaginary number to an imaginary power is actually a real number, which is 1 over the square root of e to the pi. It has a value of something. You could plug it in your calculator and figure out what the value is. So that's cool. And do more Morpheus theorem. Do I want to do that, or have I done enough? Let me think. I've done enough, because if I do Morpheus theorem, I'm just going to make even those that followed it, I'm going to lose them too, maybe. And if those that didn't follow it will just say whatever. So I covered something I call natural hate, synthetic hate, Euler's identity, which is basically that e to the I pi plus 1 equals 0. And I did a miscellaneous complex number identity, which is I to the I equals e to the minus pi over 2, or otherwise said, I to the I equals 1 over the square root of e to the pi. So love you guys, peace, rock and roll. Have a nice night.